All right, so we have now moved on to the non-calculator part of the FRQs, which means that remember that we don't have a calculator, so we typically are not going to simplify things. Okay, so a student starts reading a book at time 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differentiable function r, where r of t is measured in words per minute. So again, those are key things to think about. Selected values of r of t are given in the table below. Approximate r prime at 1 using the average rate of change of r over the interval 0 to 2. Show the work that leads to your answer, indicate units of measure. Okay, so a lot of times they don't even say using the average rate of change. They'll just say approximate r prime at 1. And so when we look at the table there, we know that the approximation of the derivative would just be that average rate of change, right? So that just means we're going to need to find r of 2 minus r of 0 all over 2 minus 0. So you want to make sure that you write that out, or you could have jumped straight to 100 minus 90 over 2 minus 0. That would have been fine. Just to show again that you understand that the average rate of change is just that change in y over change in x, which would then just be 10 over 2, which you could leave as that, but I would probably go ahead in this case and say 5. All right, but they specifically said indicate the units of measure. So in this case then, if that numerator up there was already words per minute, and then that denominator is minutes, then we know that now our units are words per minute per minute. And if you wrote words per minute squared, that would have been fine, but I think that I like the answer words per minute a little bit better. Okay, so that's your units. One thing they do often ask on questions like this is maybe interpret your answer. So again, remember that if you are having to write like a sentence or something like that, then you would need to say at 1, whatever the unit is, so at 1 minute, the average rate of change, right? Or at 1 minute, the number of words per minute is increasing at 5. So again, point being is, don't forget if they ask you to interpret it, then you would need to put the exact time there, that 1. Okay, but units was all they wanted. They didn't need to write a sentence, so we're moving on. Okay, must there be a value c on the interval 0 to 10 such that r of c is equal to 155? So this is one of our wonderful existence theorems. So this is going to be the intermediate value theorem, the IVT, because we are just deciding whether or not this specific value has to occur on this interval. It has nothing to do with the mean value theorem, which would have been saying that there's a place where the instantaneous rate of change is equal to the average rate of change, right? That's the MVT. So for the IVT, we do need to make sure that we meet all of the requirements. And so for the IVT, that means that it needs to be continuous. So we can say that since R of C is differentiable on, we could just say is differentiable, it must be continuous on, let's see, 0 to 10. So you got to say that it's continuous, but in this case, they didn't actually up here say it was continuous. They said it was differentiable. So that means you need to say something like, because it's differentiable, we know it's continuous, right? You can't just write that it's continuous. Now, if up here it had said it is continuous, then you could have just said because it's continuous, all right? So you need to give some type of logic there that because it's differentiable, we know it's continuous. And then if we could figure out what R of 0 is. So R of 0 is 90. and then R of 10 was 162. So since 155 is in between 90 and 162, so the IVT guarantees a C value on 0 to 10 such that R of C equals 155. All right, so you can say that in whatever words you know, however you want to phrase it, but something like that. And you honestly don't even need to say IVT. So if you're scared, you're like, oh, is this one IVT or MVT? I'm not sure. Just don't even write it. Just do all this other stuff and just leave that off. So if you're not sure. Okay, use a trapezoidal sum with 3 subintervals indicated by the data in the table to approximate the value of the integral from 0 to 10 of R of t dt. So we know that this is where a lot of times are either going to ask us for a Riemann sum, or in this case, they wanted a trapezoidal sum, right? So if it's a trapezoidal sum, so we can come in here and say, well, the integral from 0 to 10, R t dt, yeah, there we go. R of t dt. And so then I can come back up here and say, well, that is going to be approximated by my trapezoid. So remember that trapezoids are 1/2 times the sum of the bases times the height of that trapezoid. So that would mean then for that very first trapezoid, that first interval, right, 0 to 2, that's the height of the trapezoid, so 2, and the sum of the bases, right, this is saying that it goes up to 90 and up to 100, so then we could do 90 plus 100. And then the next trapezoid would be 1/2, 100 plus 150, and this one is an interval of 6, so that's the height there, right, plus 1/2, and then we've got this time another 2, so 150 and 162, and then times 2. All right, so it is very, very important that if they ask you for a Riemann sum or a trapezoidal sum, that you write all of this out to show it. Now, this is one where you don't have a calculator, so I would just stop there. You're done. Like, don't try to simplify it. If you try to simplify it and you make a mistake, then you're going to lose a point. So just stop there, okay? Unless they specifically tell you to get a value, there's no need to go any further, okay? While we're at it, just to remind you, like if this had asked for a right Riemann sum, right? So if it was a right Riemann sum, then we would have been using 2 times 100, 6 times 150, and then 2 times 162. That would have been a right Riemann sum. And then a left Riemann sum would have been still doing the 2, but now times 90, and then 6 times 100, and 2 times 150, right? So just read carefully to see which one it wants, but do not, and write it out, but don't bother evaluating it further than that. Just be done, okay? If it did say that it wanted the units, then in this case, because we're adding up the area under R of t words per minute, then this would be words, right? This is the total words over those 10 minutes. But again, they don't even bother to ask that, but you could certainly write words if you wanted. A teacher also starts reading at time 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by that function, W of t. Based on the model, how many words has the teacher read by the end of 10 minutes? Okay, well this time we can actually do it without approximating because we have the function. So we have negative 3/10 t squared plus 8t plus 100 dt, and we are adding it up from 0 until we get to 10 minutes. So that's the rate that the teacher was reading, and so now this time we can actually go ahead and integrate it. Now, you do need to do the integrating, right? So you're like, oh, but I thought I can just write it out and I don't have to do any other work. No, because at this point you've yet to actually evaluate it. So we do want to go ahead. So this would be -3/10, right, times a third t cubed, right, plus 8 divided by 2 t squared plus 100t. Remember, we don't need a plus c because this is a definite integral. So I'm plugging in that 10 and 0. And again, we do want to then go ahead and plug in the 10. So, and if we wanted, we could simplify those 3's there, right? So this is going to be -1/10 times 10 cubed plus 4 times 10 squared plus 100 times 10. Now, at that point, you can be done. You do not need to actually, but you've done the integrating. You've shown that you need to plug the 10 in. In this case, you wouldn't have to then put minus and plug 0 in. I mean, you could. So you got -1/10, 0 cubed, plus 4 times 0 squared, plus 100 times 0. That's fine. But in this case, since 0 is going to give you 0, if you left this part out, that would be totally fine. If this had been asking you to do from 2 to 10, then you would definitely need to plug the 2 in and show that you then would subtract. Okay?